All right, welcome, math department. We appreciate you for being here for another meeting at Belaire High School. So today's agenda for us today is unpacking the standard. Through unpacking the standard, we're working with the Algebra 1 standard, which is one of our major focus for the year, along with geometry, of course, too. But for right now, we're going to emphasize on the unpacking of the standard for Algebra 1 Concept A1, A-REI B4B, which is solving quadratic equations by inspection. And it gives us a little example here, dealing with x squared equals 49, taking square roots, completing the square, the quadratic formula and factoring as appropriate to the initial form of the equation. Recognizing when the quadratic formula gives complex solutions and write them as no real solution. All right, so what are the key vocabulary terms that we probably need to know in this particular standard? I think we need to know some things real quickly. So what vocabulary words we need to know in this particular standard? Polynomials, all right. And then quadratics. Okay. Okay, so we got polynomials. I have each of you should have the paper in front of you. I'm just going to go ahead and list it up here. So, okay, students need to know some certain vocabulary that we need to know. So I'm going to put vocab right here. The vocab. What's the words? Polynomials.
Polynomials, quadratics.
All right, quadratics. What else?
The difference two squares be?
All right, the difference of two squares.
The square is in general.
Square root.
All right, square root. Probably need to refresh your memory on square root. What else?
Distributive property.
All right, distributive property. Ooh, that's a fundamental.
Factor. Factor.
Definitely a factor.
Man, factor. So we got a lot of basic concepts that need to be done. Zero property. Oh my.
Zero product property.
Okay, let me put zero.
That's very important when it comes to quadratic.
Product.
And also, the most important thing they need to know, they need to know how to be able to work those problems, multiply, and then be able to go forward and backwards, which is the division of it.
Okay.
So they need to be able to fall forward and backward, or factor forward and backward. If that makes sense.
Factor forward and backwards.
Yeah,
So-
FOIL forward and backwards. I
Okay,
say
so-
that FOIL method.
So you say
FOIL method.
FOIL method? Okay.
Yes.
Now, one thing with Eureka's gonna get on you about
That's what
about
I'm saying.
that.
That's what I'm
So-
saying. So with the tabular method, you take the tabular
There you
method
go.
forward,
Okay.
and the
There
backward
you
will be the division.
Yeah.
So tabular forward and tabular backward.
Yeah, you need to know how to do that. Forward and back.
Rectangular array.
Because one of the things we're trying to get away from the FOIL method is because it does not necessarily show us distributive property. Although it's understood, the kids don't really see the distributive property. They see a technique,
Yeah.
that's great, but they don't really see the fundamental principles, all right, that we need.
My class, we use the box method.
That's
Um,
tabular.
And that's a tablet, that's box method.
Oh, okay.
Yeah, or
It's just another way to say it.
it's actually an array, but the more terms you have in the polynomial, the more it becomes rectangular or either the box,
Right.
the more it's spread.
All right, so let's go back real quickly. Back to the top here. Next question: what verbs or actions within the standard should students master? What verbs should a student master? What do you think are some of the verbs that we should master here? Just by looking at the standard. Verbs meaning task.
Factoring.
All right.
Yeah,
Factoring. We said it earlier. We already pretty much said it earlier.
They completely square.
We'll go back and
Solving
review that.
equations,
Yeah,
Solving, oh yeah, solving equations is important. So we can go back to solving.
and then those methods to solve it would be factoring, the quadratic formula, completing the square.
Okay.
Those would be the methods.
All right, right, so you would say methods to solve. Okay, what else?
Showing those steps.
All right, showing steps. All right. What conceptual properties or theorems should students know? I think we listed some earlier already, based upon you just using the vocabulary. But I did see some theorems in there that we probably need to, address, like zero product property, right?
Yes.
That was one. That was
That's
one
the most
major one
important
that we needed to address. All right. All right. Let's look at it.
Very important.
Let's look at it. Another one. Any others that you can see? That you could see? What about the perceptual knowledge? In other words, what to do. We said solving is what to do. Computational factoring, that's another procedure. So the vocabulary probably took the bulk of and answered most of the questions. How would students represent what they know? How would students represent what they know? What are some things that we need to know? For example, let's look at this right quickly.
Well, with the tabular method, they represent, they know that if they know how to place the terms on either side. And they need to know that even when they place the term, the one term on the top, one factor, they don't have to, they're not locked into one side. They can actually use it on either side. Meaning that way they understand that A times B equals B times A.
Okay. Yeah. So proper use of the table.
Yes.
Right? Proper use of the table. Yeah.
I will also say with solving the equation, you can give them one problem and they should be able to know, okay, well, it'd be best for me to use the factoring, or it'd be best for me to use the quadratic formula.
Yes.
So
Which
if they're
is best.
right, if they are able to determine, because there's several methods that we're going to teach them of how to solve an equation, but if they're able to justify which one is better to use, then that shows that they're able to understand solving. Because if an equation is not factorable, if it's not gonna give you an integer or whatever, then you most likely use quadratic formula or complete the square root factor.
Absolutely. So determining which is best.
Right.
So we want to create some questions that does that, right? Also, do we need some comparison problems where we're looking for mistakes? That would be a more, so kind of looking for mistakes. Any other type of questions that we probably would want them to show evidence of what they know?
They should also know the number of solutions. So it would have no solution, one solution, or two solutions.
Okay. The number of solutions.
Right.
And then non-real solutions.
Non-real. So we want to create some problems like that, right? We want to make sure that there's some problems like that. Finding the number of solutions, non-real solutions, and maybe one or two solutions, that sort of thing. We need to create some problems like that on our assessment, all right? Okay, so let's kind of move forward real quickly since we addressed all. These are some suggestions, real quickly. These are some suggestions. ANET suggested explain how complex solutions affect graph of quadratic equations. Look at that. So complex solutions are even a part of this, right? And then how they affect graphing quadratic equations. Solve quadratic equations in one variable by simply inspection, taking the square root, factoring, and completing the square. So these are some different how to solve these types of equations. All right, another suggestion. Understand why taking the square root of both sides of an equation yields two solutions. That's basic algebra 1, right? Oh yeah, that's very important that we know how to do that. Use the quadratic formula to solve any quadratic equation, recognizing the formula procedures of all complex solutions. Write the solutions in a complex form where A and B are real numbers. That's also suggested by the Louisiana Standards, where they've aligned certain lessons in the Eureka lessons with this particular standard. So you look at 1.17, 4.5 through 4.7. And those I want us to kind of look at also, all right? So we're gonna do that on the back end very quickly. Let's see if this is a question that we would like. Here's some sample questions that we would like. Read that question real quickly. Let's see if we would like that question. Which equation have no real solutions? Select all correct answers. Would that be a question that you would like? And you would think, which DOK that would be? DOK 1, 2, or 3?
That would be three.
All right. So you would say, which equation have no real solution? Which one? DOK 1, 2, or 3?
Yeah, you gotta understand it, but
Okay. One person say 2, maybe. Okay. Let's erase this part.
That would be DOK too, because you have more than one answer to select from. It's not just one answer.
It's not just one answer, right?
oh, that might
I think, cause how you broke it down, I think you said DOK level 3 was the comparison and then error analysis.
Yes.
And then DOK 4 was to construct something, design something. DOK level 1, we said, I'm trying to remember what you said.
More conceptual.
Conceptual, and then 2 was procedural.
Procedural.
So that would be probably more like a,
That is like, in other words, which equation has no real, so that's an identification type of thing. So that's more of a DOK 1, actually, because we're just identifying which one is what, the real root, okay? So this would be classified probably as DOK 1, all right? So we can probably use that one, maybe. Which quadratic equation has non-real roots? Non-real roots. Ooh. Now we see the answer, but if we had to say which one has the non-real roots, that would cause us to do procedures, right? So that would be a DOK what? DOK 2, because you have that's a procedure. All right? All right. So that's looking at it. Okay? And I'm gonna pause right there.